So our project is real-time age, emotion and gender detector. So what is this? A real-time age, emotion and gender detector is an intelligent computer vision system that uses machine learning and deep learning techniques to analyze human faces through a live camera feed. This system captures the images or video frames and detects the face and classifies person's age, group, gender, emotional state, just like happy, sadness, our angerness, surprised, neutral, etc. instantly. So it combines the concepts of image processing and pre-trained models to perform accurate predictions. This technology has wide applications in human-computer interaction, security system, marketing, healthcare, and social robotics, where understanding human attributes and emotions in real time is very, very important. Now my fellow continue. Aritra, please.
Yes, sir. As Devoshmita said, our program is all about predicting the emotion, the gender, and the age. Here is the program code, as you can see. And in the next slide, I have included the final output. In the first picture, we can see that the age group is in the range between 15 to 20. The gender is female, the emotion is angry. And according to that, we have also displayed a message. For example, for angry emotion, we have given the message, take a deep breath and stay calm. For the next one, the emotion has changed to happy, and the message has also changed. And for the next two outputs, we can see that the gender is male. For the previous one, it was female. For the next one, it is male, and the age group has also changed. So has the emotion. For the first one, it is angry. For the second one, it is sad. And for the next one, we have included a face of a kid. So we can see that for the first image, the age group is 4 to 6 years, and for the next one, it is 0 to 2 years. So we have also changed the message and the emotion accordingly. So we can see here we have used a lot of test cases to analyze this project, whether it is working properly or not. So that was all about our project, sir. Thank you.
Thank you.
The Indian Cities Weather Analytics Dashboard app that we have made is a Python-based tool that provides real-time weather data and forecasts for major cities. We have made this using weatherapi.com. It fetches the current conditions and a 5-day forecast, presenting the information in tables and plots. The dashboard uses Gradio for a clean interactive interface, allowing users to quickly view temperature trends, humidity, and wind speed. This project demonstrates the integration of APIs, data analysis, and interactive visualization in a user-friendly application. We have made this interface. Here we'll enter the city that we need and whose weather we need to see. The city text box lets the user type the name of an Indian city, for example, Kolkata, Mumbai, Delhi. When the user clicks Get Weather here, the dashboard fetches current weather and a 5-day forecast for that city. Then displays a summary, a forecast table that will be seeing soon, and plots of temperature and wind speed. So here is the statistics displayed. We can see the temperature here. We can also see the condition. We can also see humidity, and we can also see the wind speed over that city in that particular time. There are also some more data that we can see through that app. This table shows the 5-day weather forecast for the selected city. Each row represents a day and includes date, maximum temperature, minimum temperature, average temperature, maximum wind, and precipitation. We can also see the graphs. This temperature graph shows the 5-day trend of maximum, minimum, and average temperature for the selected day, and wind speed graph also shows the displays the maximum wind speed forecast for each of the 5 days. And the project in action here here we have the screenshots. And the future aspects of this project, we will also add multi-city comparison to view weather trends of multiple cities at the in the same time. It will also include hourly forecast for more detailed analysis. It will integrate historical weather data to analyze trends over time. We will also add air quality and pollution metrics for each city. We will also enhance the GUI with interactive charts with using plotly or dash, implement notifications or alerts for extreme weather events, and make the dashboard mobile friendly or deploy as a web app. We have taken the references from here, and that's it for our presentation, sir.
Working with computer vision and DeepFace. So initially, what we made is we wrote the code so that we have to upload the image, and from that image, the code tells us the gender of the person, the age of the person, and the emotion of the person. So that was the initial stage, and right now we are also working on the webcam version where we can open a webcam and it will detect our face, tell us our age and the emotion right now that we are showing. Farhan, can you show the code of the image one?
Sure. So this was the initial version that we made. Here we are using DeepFace and OpenCV to analyze the images, and it gives us our. Then we have written a code which will tag the image using a green box that detects the face and displays the age, gender, and emotion. That was the initial idea, and we are using numpy array which converts the image address into an array address which displays that function of working the emotion analysis. And after this, we have added a new feature for the webcam, which Farhan will show.
So my primary role was in this project was to build a system which will use the webcam in the real time for the analysis. When we started, the first major issue of our code was the bottleneck, because DeepFace is a really powerful model which directly analyzes the frames. Hence, we were getting 1 or 2 frames per second. This was completely unusable for any live interactive application. To solve this, we implemented a smarter process of pipeline. The main optimization was to stop analyzing every single frame. Instead, we only run DeepFace analysis on every nth frame. For all the frames between, we use a faster and lightweight Hazar cassette detector as a feedback. The simple trick ensures the bounding box of the face remains visible and feels responsive, without the heavy computational cost on every frame. To make this work smoothly, we in the live webcam we use multi-threading and queue. One thread is dedicated solely to capturing frames, while separate workers thread handles analysis. This prevents heavy processing from freezing the video, keeping the entire system fluid, and also add and we also added frame down sampling to reduce the data load and mirrored the feed so it looks more natural. It will look better if I just run the code. So as you can see, the camera is working and the FPS counter is 20 to 27. But this box which we are using to keep in place, it generates randomly, but not on the face. So that is the problem we are currently facing, and there's no other problem in this. I would like to conclude. I will ask Krishna to conclude actually.
So till now, this is what we have made for this project, but we are working on a few more features. Like currently, the version which Farhan showed regarding the webcam one is working on that feature branch, and I am trying to integrate a few more features like the detecting accessories. What kind of accessories a person is wearing from their photo and webcam on a different branch. And then Misbah is also working on like poster detection functions. So we are all working separately on different feature branches, and then later, if each one works correctly, we will merge it into a single branch for the final project, main project. This way, our development workflow stays very efficient and professional. Thank you. So this was our project.
Thank you. Very good presentation.
An extractive summarizer that works on the framework of BERT that is developed by Google AI. So this summarizer just takes in a chunk of text and summarizes it to specific ratio or a percentage of the user gives. So the next slide contains some of the screenshots of the UI. So this is the UI, simple UI, just a text box that inputs the text, and there's a slide that the user can input the summary ratio in percentage, and there's a summary box. And I've just the first screenshot shows the summary of the 250 words text that is summarized to 25%, and the second one is shorter text of just 50 words, and that is summarized to 35%. So that is our project, sir. Okay, so these are the screenshots of the UI. The first one contains 250 words, a chunk of text that contains 250 words, and it is summarized to 25% of the text. And the second screenshot contains a shorter words, a 50 words text, and it is summarized to 35%. So these are the UI screenshots, and I'll just make a quick demo of the running project. So I have the terminal open.
Okay,
Okay,
good try.
okay,
Good try.
okay, sir, okay,
Carry
sir.
on.
Riya Pathak and Ritresha, we are a team and we are working on a project that is digit recognition using deep learning and computer vision. Now, why we need it? So, a machine should understand that what are the digits that are written on an image. We can use it for cancer cell detection and all. I have a slide on that also. So this is a method of how we did the project. We took a data set that is this MNIST data set. Here 60,000 images of 0 to 9 digits are here, and we are only training the model. We are experimenting the model on only 10,000 pages, 10,000 images. Now these are the outcomes. Here the first outcome is about training the machine model. That is, we are training the 60,000. Here it is written as shape of extent 60,000 and y trend 60,000. Then we are getting the results of only 10,000, 10,000. And on the second one, it is the accuracy of the model. Here we are getting a 99% accuracy, and these are the results in real life uses, and this is the conclusion. Okay, so here it's a Google Colab. So here we are taking the MNIST data set, then we are importing the images. Here we can see that we are taking 60,000 images in 20 cross 28 cross 28 cross 28 cross 28 dimensions. Then we are training only 10,000. We are getting the results for only 10,000. Now digits are getting their unique numbers, and here we are importing the second part where the images will get recognized by the machine. And here if we run it, it will take a lot of time. We will get digits like this, images like this, and results like digit 5, digit 9 and digit 7 like this.
Hello, thank you.
Yes, sir. Good morning, sir. My name is B.P.Poddar. Today I will present our idea and design of a face recognition attendance system using Python. Normally, attendance system is taken manually, which takes time and may have mistakes or even proxy attendance. Our project is designed as a solution using face recognition to mark attendance automatically. Even though I am not showing the practical implement today, but this concept is clear. Basically, the technology can make attendance faster and more accurate. Our system is designed with three key features. Number one is the real-time and accurate attendance. Number two is the use of Python and OpenCV library for face detection. And number three is the database management. And next thread is my friend.
Hello sir, myself Akash Das. I present the slide number 4, that is technology stack. So the backbone of this system is Python. Using its robust libraries, we implemented face recognition with efficiency. Specifically, we used the OpenCV library, which allows real-time face detection and recognition. Together, this technology stack ensures both power and reliability. And then slide number 5. Next, it performs data processing to analyze and verify identities using face recognition algorithm. Finally, the system generates an attendance report which can be accessed easily by educators and administrators. This end-to-end process saves time and ensures accuracy. So, in conclusion, our system makes attendance faster, error-free, and very useful for schools, college, and organizations. So that's all. Thank you.
Thank you, sir.
Okay, very good.
Today we are presenting a presentation on a digital diary that we have made using Python. We are Rohan Manna, Rupsha Moitro and Ruprekha Rajnin Choudhury. So what is a digital diary? A digital diary is an electronic journal where users can record thoughts, experiences and crucially their daily moods. Unlike traditional paper diaries, digital versions offers enhanced organization, searchability and analytical capabilities. So here comes the question, why track modes? Because it promotes emotional intelligence, identifies patterns and triggers, supports mental well-being and self-care, and provides data for personal growth. I would ask Rohan to go deeper and give deeper insights on the data.
So the problem statement beyond traditional diaries. So first we have lack of data inside. Traditional diaries are rich in qualitative data and the lack quantitative analysis, making it difficult to spot trends or the correlations in mode fluctuations over time. Second, we have inconvenient analysis, manually reviewing pages of entries to find mood patterns in time consuming and often inaccurate, hindering effective self-assessment. Third, storage and accessibility. Physical diaries can be lost or damaged and the accessing parts entries remotely is impossible. So digital solution offered secure searchable archives. Rohan Manna.
So, objective. It will develop a user-friendly system for daily mood logging. It stores mood data efficiently for easy retrieval and analysis. It generates clear and informative monthly mood graphs. It empowers users with a visual overview of their emotional well-being. It leverages Python's data processing and visualization libraries to create an accessible tool for self-reflection. The technologies I have used in it's Python, the core programming language, and Matplotlib, the library. Uh, is the system design. Is the code here I have imported Matplotlib as you can see and imported datetime and import JSON. The code as you can see here comes digital diary. It's the output code.
So sir, this is our PPT of the project is health and fitness tracker. We develop it using Python and sir, the purpose of our project is to help individuals to monitor and manage their fitness journey in a simple and effective way. And here is a slide of why to track our fitness. It's because it encourages goal setting, provides progress monitoring through visualization, and support informed lifestyle decision with data-driven insight. And there are some core objectives of this tracker, like workout logging. It's record exercise routines. Then meal tracking. It's monitor diet and nutrition and weight management. It tracks our body's weight trends and step counting. We all use it to step our to monitor daily activity and various performance we can do with this tracker. And the next slide will be presented by my fellow mates, Devashrita and Arijit or Arijit. Arijit, please continue.
Yes. Hello, sir. Good evening. So here we are showing about system features and technology stack. So what are the key features of our project? So we have to create our profile first. Then we have to upload our daily and historical summaries and data export in CSV and visual data plots. Here we are used Python for code development, SQLite that is used for local data storage, pandas are used for data analysis, and matplotlib is for visualization. Implementation and workflow. Here we are showing that flowchart. CLI input, then we are going to the SQLite storage and pandas processing and matplotlib visualization. After that, data enter via command line interface or CLI, and then secure local storage ensures the privacy. After that, my fellow teammate Devasrita Mukherjee will continue.
Hello, sir. Good evening. Now it's the conclusion parts of the PPT and the future vision. The benefits of this purpose is empowers user to control health, provides meaningful insights, flexible foundation for upgrades. And the future scope is GUI for better usability, integration with wearables, advanced analytics, cloud synchronization. This is the entire PPT, sir. Thank you.
Okay, very good.
Yes, sir. So first of all, I would like to tell the name of my group mates. That is Dhruv Mandal, Kaushik Pradhan, and Kaushik Sharkar, and I am Deepak Shah. So our project is about a weather app which we made using Python and Python libraries. Kaushik, please shift to the next slide. Yeah. So the first thing is that how our project works. The first thing is that is it takes the user input as the name of city which we want to know the weather of, and then it fetches the data for the weather from the API we used in the project, and then it create a chart for like visual of that data, and then it shows on the screen which we can relate and understand what is the weather about on that city. The next slide, please. So the main things what our project we used, that is Python for main language, and then NumPy for handling the numbers and calculation, and then pandas for organizing the weather analysis. Okay, and matplot for plotting the graph and chart of that.
Graphs and charts, and Tinker for graphical user interface, which is also known as GUI. And sir, next, here are some references for API. We used Open Weather App API, and the other is Weather API. And for learning sources are W3 Schools, Greeks for Greeks, and GitHub Reopen Sources contributions. And for designing this site, we used ChatGPT and Canva.